Often we want to combine two or more sets, and we can do this in various ways. The most common being taking the union of two sets or taking the intersection of two sets. The union, which we represent with this U symbol, is the set of all objects that are in one of the sets or in both. Usually we'll just say it's in set A or it's in set B. In math, when we say or, we'll always mean an inclusive or, one or the other or both. So one way we can combine two sets is to take the union. Another way we can combine two sets is to take the intersection. The intersection of two sets, defined with this upside down U symbol, is the set of all elements that are in both sets at the same time. So the union, one or the other or both. The intersection, just what's in both. Remembering which symbol is which, you can think of that U shape, technically called a cup shape. That looks like the letter U in union. And then, the intersection symbol is the one that does not look like the letter U. So let's just look at a quick example. Here are a couple of small sets given in roster notation. Their union consists of everything that's in A, 1, 2, 3, 4, 5, and then also everything that's in B. So we don't have -2 yet. We already have 2, so we don't need to say that again. We already have 4, we don't need to say that again. And then we have 6. So we can list A union B as 1, 2, 3, 4, 5, -2, and 6. Notice when we're listing a set, the order doesn't matter. We could put these numbers in order, right? We could say -2, then 1, 2, 3, 4, 5, 6. But in listing a set, the order doesn't matter. Notice also that we did not say 2 again. We did not say 4 again. Repetition also doesn't matter. Okay, so that's the union. We list everything in A and then put in everything extra that B brings. The intersection, A intersect B. I'm going to go through A and find everything that's also in B. So 1 is not in B. 2, that's in B, so that's going to be in the intersection. 3 is not in B. 4, that's also in B, so that's going to be in the intersection. 5 is not in B. So A intersect B is just the set containing the numbers 2 and 4. A union B contains everything that's in one or the other or both. A intersect B contains just what's in both. And thinking about this a little bit, it's easy to realize that sometimes we're going to have sets that don't have anything in common at all. The intersection of two sets might be empty. That is, it might not contain anything. When we want to describe a set that doesn't contain anything, we use this symbol to represent what's called the empty set. The empty set, there's just one yeah, right? What would distinguish between them? So let's find a couple more intersections. We'll find a couple of unions, and then we'll talk about what specifically the unions and intersections of intervals look like. So here we have the interval from -4 to 3, including 3 but not -4. So that looks like something like this. And then we want to intersect that with the integers. So we want all of the integers in this interval. -4 isn't in, right? -4 is not included. But we'll have -3, and then -2, that's still less than 3. -1, 0, 1, 2, and then 3 is included in the interval. But then we're done. So intersecting this interval, With the integers, we get just a list of integers. Next, we have negative infinity to 2 intersected with 1 infinity. So I'm going to sketch that as well, because that's going to help me see what the intersection looks like. So I have two numbers here. Right, I don't need to put in points for negative infinity and infinity. I have 1 and I have 2. So negative infinity up to 2, that looks like that. 1 to infinity, that looks like that. The intersection is just this part that's on both. So the intersection starts at 1, goes up to 2. It doesn't include 2 because 2 is not included in that first interval. So the intersection of these two starts at 1 and goes up to 2. Okay, here's another one. So the interval from 0 to 1 not including either number, intersect with the integers. Well, 0 isn't in that interval, right? It has the round bracket. 1 isn't in that interval. There aren't any integers in between there. When we take that intersection, there's nothing there. So this is the empty set. The interval from -3 up to -1 intersect with the interval from 1 up to 3. Looking at this, we see that, there's no overlap. These intervals don't overlap. So again, their intersection is empty. Okay, so when we take the intersection of an interval with the integers, well, we got just a list of integers. Intersection of two intervals, we got another smaller interval. Sometimes an interval doesn't overlap the integers at all. Sometimes two intervals don't overlap at all. So those are two different ways we can get the empty set. Next, let's take a look at some unions of intervals. So we've got the interval from -3 up to 4, union with the interval from 2 up to 6. So let's see, the numbers I'm interested in here are -3, 4, 2, and 6. Notice I'm not making any effort to make these evenly spaced. I only care about what order they come in. So -3 and 4 get filled dots. 2 and 6 get empty dots. We want the union. So we want everything in this first part, everything in the overlap, everything in the second part. The union is going to start at -3 with a filled in dot. It's going to end at 6 with an empty dot. And it's going to cover everything in between. Right? 2 is not in the second interval, but it's in between here, so it's in the first interval. The union of these two intervals starts at -3 with a filled dot, ends at +6 with an empty dot. So we go from -3 up to 6. Okay, next, the interval from -8 to infinity, union with the interval from 2 to 5. So let's see, what numbers are we interested in here? We've got a -8, we've got a 2, we've got a 5. Our first interval starts at -8 with a filled in dot, continues all the way out to the right. Second interval starts at 2 with an empty dot, ends at 5 with an empty dot. And again, we want this part here, and this part here. So it looks like in this case, right, this interval from 2 to 5 is entirely inside that interval from -8 to infinity. So in this case, the union is just -8 up to infinity. Okay, next one. We've got -infinity up to 2, union with 1 to infinity. So the numbers we're interested in are 1 and 2. Our first interval, we have an empty dot at 2 and go all the way off to the left. Our second interval, we have a filled in dot at 1, go all the way off to the right. Oh, this time, when we look at, this part and the overlap and the part over here, it looks like that's covering the entire real number line, right? We're catching every real number. So we can just say that this intersection is all real numbers. Now, this is the way that a normal person would write this. Sometimes we're trying to type something into a computer that's explicitly expecting interval notation. And in that case, we can say this interval has no left end. So we have -infinity. This interval has no right end. So we have +infinity. So instead of just saying R, the symbol for the real numbers, we can also say this is the interval from -infinity to infinity. Okay, last one. Here we have -infinity to -4, union 1, 3. So we've got -4, 1, and 3 as the numbers we're interested in. So our first interval is -4 and everything to the left. Our second interval is everything between 1 and 3. If we were taking the intersection of these guys, this would be empty. But the union is going to consist of, this stuff here and this stuff here, but not this stuff here. And so that's not an interval. If we want to describe that using interval notation, this is all we got. Right? So because there's no overlap, we're just going to write this as our first interval, union, our second interval. So because there's no overlap, we can't combine these into one interval. We have to keep writing that with the union symbol. So what happens when we combine two intervals specifically with these operations, intersection and union? Well, the intersection of two intervals is either another interval or there's no overlap at all and they're empty. The union of two intervals might end up being another interval. It might end up being all real numbers, which we can express as an interval. Or it might be neither one of those. It might just have a gap. And if it just has a gap, then the way that we express that union is just by using the union symbol.